Okay, section 6.6, we are graphing inequalities in two variables. So that means we're going to have both an x and a y in some of our equations. So it's going to look something like this. I'm going to start by doing example 2 on page 353. So we start by them just saying, graph this. Y minus 2x is less than or equal to negative 4. So we got to think about this as if we were just had the equation. If we just had the equation y minus 2x equals negative 4, then we would be graphing by doing y equals mx plus b. So we're going to just treat our inequality sign as if it is an equal sign and start by graphing a line with y equals mx plus b. So I would have to get y alone, which means I'd have to add 2x. And this inequality would be y is less than or equal to 2x minus 4. So now I'm going to find the points where this line is, but I won't draw it in quite yet. So the y-intercept, remember y equals mx plus b, the y-intercept in this problem is negative 4, so I put a dot on negative 4. My slope, my m, is 2, which means 2 over 1, which means I'm going to go up 2 and to the right 1 and put a dot. And I'm going to keep doing that. Up 2 and to the right 1, and put dots all the way across. And I can go down in the other direction also. Now, when I go to draw the line, I have a rule that if it is greater than or equal to, you're going to make a regular solid line like we're used to making. If it's just greater than, we're going to make a dashed line. Same thing with, I'm sorry, I said less than or equal to. So same thing with greater than or equal to, it'll be solid. And same thing with just greater than, it'll be dashed. So it takes the line under it for it to be a solid line. And without that, you'll make a dashed line. So this problem is a solid line. Now, because it's an inequality, I'm going to be shading one side of the line, and that whole shaded area will be my answer. So I have to decide which side of the line to shade. I'm going to show you the long way and the short way to do that. The long way is to find a test point. And the easiest test point to use is 0, 0. So this is going to be my test point, 0, 0. And I'm going to put that into my equation, y is less than or equal to 2x minus 4. Or you could put it into the original equation. You can do either one. So putting it into this equation, my x is 0, my y is 0. So I would have 0 less than or equal to 2 times 0 minus 4. That gives me 0 less than or equal to 0 minus 4, or negative 4. Then you look at this and you decide, is this true or is it false? Is 0 less than negative 4? No, that's false. So I did my test point in this area and it came out false, which tells me I'm not going to shade that area. I'm going to shade the other side of my graph. So you're going to take your pencil lightly and shade in the whole other side of that line. And that's the way your answers are going to look. I'm going to be looking to see, is it a dashed line or a solid line? Do you have the right y-intercept, the right slope, and have you shaded the correct side of the line? Now I said there was an easier way to figure out which side of the line to shade. And that works like this. Y is greater than, or y is greater than or equal to, always means that you're going to shade above the line. So when you get that y alone, you'll shade above the line. Y is less than, or y is less than or equal to, will mean shading below the line. And you just have to be careful about knowing which one is above and which one is below the line, especially when the lines get kind of steep. Okay, so in this problem, above the line is going to be to the right of it. This is above. And below the line would be this side, below. If you kind of think about it, above the line, if this line, the blue line right here, is my line, if I put a marble on top of it, it would roll down. But you can't put a marble on the other side of the line. You can't put it below the line. So this is sort of a rule that you can just remember. If it's greater than, or equal to, you'll always shade above. Less than, or equal to, below. But the other ways, you can always check out the test point. So the other rule that we had to remember, if it's y is less than or y is greater than, if it's just less than or greater than, you're going to have a dashed line. If it's less than or equal to or greater than or equal to, you'll have a solid line. Oops. Okay, let's do another one. Okay, this time we're going to graph the following. X minus 2y is less than 4. So we always have to get it into y equals mx plus b form. So I'm going to get y alone. I'm subtracting x from both sides. I get negative 2y less than negative x plus 4. In order to get y alone now, I have to divide everything by negative 2. And I'm dividing by a negative, which means that's a red flag problem, which means that's going to have to change the direction of the inequality. So I'm now going to have y greater than, so I had negative x over negative 2, that's 1/2 x, and 4 over negative 2 would be minus 2. Now I'm ready to graph. My y-intercept, in thinking about y equals mx plus b, my y-intercept is negative 2. My slope is 1/2. That means up 1 and to the right 2. So I'm going to keep going up 1 and to the right 2. I'm also going to go down 1 and to the left 2 until I have dots all the way across. Now, before I make my line, I'm looking to see that I have just greater than, so that's going to mean a dashed line. Then I have to figure out which side to shade. Y is greater than means shading above the line. So I'm going to be shading in this area here. I could always check out my test point. So my test point this time is 0, 0. I'm going to pick 0, 0. My equation is y is greater than 1/2 x minus 2. So both my x and my y are 0. Is 0 greater than 1/2 times 0 minus 2? 0 greater than 0 minus 2? So the question is 0 greater than negative 2? That is true, and that's why shading in where the test point is would be correct. So I've shaded above the line, and that's correct. And this one is done.